Heinemann Higher, Chapter 6, Differentiation, Exercise 6S, mixed questions at the end. Question 8, showing that functions are either increasing or decreasing, or never decreasing or never increasing, like this one here. Now normally with an x cubed function, if you've got extra terms, it would look like this. So sometimes it's increasing and sometimes it's decreasing, but not the basic one. The original one, the one that's just x squared, x cubed, goes like this. It's increasing most of the time apart from that one little bit there when it's momentarily stationary, so you can't say it's increasing all the time. But what you can say is it's definitely never decreasing. So how would you show that technically? Well, differentiate it to get a picture of its gradients. So that'll be 3x squared, and then immediately, as soon as you've got an x squared term, that can never be negative. And that would be the solution to that. It can be equal to 0 otherwise, unfortunately. So in this case here, you would say, since x squared is always greater than or equal to 0, that means that f dashed x is always greater than or equal to 0, which means that the function itself is never decreasing. I can't say it's always increasing, unfortunately, because of that equal to. If I had a different expression here, if this had come to 3x squared plus 1, well, the lowest I can get to is 0, so the whole expression can never get lower than 1, then I could indeed say, if that were the case, f dashed x is greater than 0, in which case it's always increasing. But the best I can do here is to say it's definitely never decreasing. And so part B, right, same again. Show that this is never increasing. Well, the derivative will tell you that, because the derivative tells you how it's heading at each value of x. It gives you its gradients. So what would that be? Constant term, that's gone. Multiply with the power, negative 6x squared. And then it's the same again. Since x squared must be greater than or equal to 0, that means that a negative times it means that it's always going to be less than or equal to 0. Now again, you can't say it's always decreasing because there's the one time when it's equal to 0. So instead of saying the function is always decreasing, the best I can say is the function is never increasing, which means that f of x is never increasing. There it goes.